Okay, so we're doing complex plane again. This is where you have a real part. A plus BI is a complex. This number here that doesn't have the I is considered the real part, and the number that has the I is considered the imaginary part. And we're going to be dealing with all kinds of things with these two things for the next 2 weeks. And then we're going to test next Thursday, the 20th. Not this Thursday, but the week after. We're going to graph these. We're going to add, subtract, multiply, divide them. We're going to find the distance between 2 points. We're going to find the midpoint. And you remember your distance formula, midpoint formula from Algebra 1? Same story right here. The difference on these is, in Algebra 1, we have an XY coordinate. Here, we call this A plus BI an A and a B coordinate. Oops, but they are in the same thing as the XYs. We can rewrite these as AB and drop the I off, but this is the same thing as the XY from Algebra 1. Everything's the same except for the I part. All right, so we're going to go through this thing and see how it goes. So the absolute value is again, absolute values are these marks on each side. It's just the square root of the real part plus the B part without the I. You don't put the I in there when you're doing the absolute value. You just use the number part. Okay, and then the distance between two complex numbers is exactly the same thing. Now, I put R and S here because you can use any variables you want. These are just two complex numbers right here. Okay? And it's going to be just like before. If you have x1, y1, x2, y2, if you plug those in where the a's and the r's and the b's and the s are, then this is exactly the same formula as distance formula. Okay? But they use different letters for this than x and y. And then the midpoint's the same thing again. It's x1 plus x2 divided by 2. And y1 plus y2 divided by 2. That's what it was in Algebra 1 and Algebra 2 and every other time. Same thing here, except we use the letters differently because we let complex numbers be written like these up here. And then graphing is the same thing. We think of A plus BI as being AB. If you notice, I've changed the y-axis to the I. Because whatever the number is that goes with the I is the y value, and whatever number doesn't have an I with it, that is the x value. So for instance, if I want to graph, let's say, -3 plus 2i. Oops. I take that back, no parentheses. If I want to graph -3 plus 2i, I am thinking about this as the ordered pair -3, 2. Now, we don't have to write the -3, 2, but it's -3 plus 2i. That means I'm going to go left 3, and I'm going to go up 2. I'm going to put a little dot right here, and you can write the ordered pair like that, or you can just leave it -3 plus 2i. That dot would represent this imaginary number. How many are thumbs up on how to graph these? Now, if they want to know the absolute value of this thing, okay, up here we would simply do the square root of -3 squared, because this is the A part. That 2 is the B part, and then we put plus 2 squared, and we would get the square root of 9 plus 4, which is the square root of 13. Got the idea? Okay. Now that would represent the distance, the square root of 13. That would be the distance from the origin going out here to this point, would be this square root of 13, that distance right there. Okay, that's what that represents. You need 2 points to do these others, so we're just going to go and do some problems off of the homework. Now, you guys have this first part. They got a graph up here, and I'm sorry I ran these off in the copy machine, put a big black line over here. It's kind of hard to see this out of your book. I'm going to do number 210 for you. You're supposed to put down which one of these letters goes with 2 plus I. So I hope we all know that 2 plus I, what's the coefficient of the I here? What? 1. So we are looking for, where did they put a dot? At 2, 1. Does anybody see one up here where they did 2, 1? Looks like to me it's this one, right? So for number 10, number 10, the answer would be A, because you're just supposed to put down which one of these letters goes with which one of these. Are we thumbs up on that part? Okay, then the next part is up here, says they want us to find the absolute value of these. So I'm going to do number 19. I want the absolute value of this. So we're supposed to know that that's going to be the square root of 4 squared plus negative 6 squared. And 4 squared, I hope we know, is 16. And 6 squared is 36. And we add those two together and we get the square root of 52. Now, you can simplify that because I'm sure on this next test we're going to have some multiple choice stuff, right? So I'm assuming they're going to simplify the square root of 52. So you're going to have to take and break down 52. So 52 breaks down to 2 times 26, and that's 2 times 13. So you have a pair of 2's inside, so that means you can bring a 2 out and the radical 13 would stay in. I'm assuming that's how they'll probably write the answer on the test for multiple choice. I don't think they're going to leave it square root of 52. How many are thumbs up on that? This all should look really familiar to you, I hope. The only difference is we're dealing with eyes now. Then this part down here says adding, and I guess this is all adding like terms. So how am I going to add 3 plus I plus 2 plus 5i? What am I going to do? That's two. These are two imaginary numbers right here. Oops, we're going to do 22 here. 5 plus 2i plus 3 plus 4i. Anybody know what we're going to do? Huh? No, there's what's between the parentheses. What do you got right here between the parentheses? That means do what with them? Add them. There's a plus sign there. So we're going to add them. What do you look for when you're adding numbers? Like terms. We're going to do the same thing here. So what's like 5? Anything over here like 5? What's 5 plus 3? 8. You got a 2i here. Anything over here like 2i? So what's 2i plus 4i? 6i. We're done. Don't make it harder than what it is, please. Okay, coming down to the next part, it says the same thing. We're supposed to add these two together. I don't know why we need to do it on a plane, but I guess we do. So what's the real part of these? Well, maybe we should rewrite it. I don't know. So let's say it's 5 plus 6i plus 1 minus 1i. Because if you notice, all I've done is took the real part and the imaginary part, and I wrote them like they were up here. So what do I get when I add these like terms? Somebody? 6 what? 6 plus 5i. You're done. Thanks. Next part. Oh, how many are thumbs up on that? Adding them from the graph. Just changing back to the other kind. Now we get down here. Now this is the harder part. It's subtracting. You notice they all have what between the two parentheses in the middle now? We got a minus sign. Do y'all see it between them? Before it was plus, so we're adding. Now there's a minus sign, so we're subtracting. What did you do back in algebra when you had a minus between the parentheses? Anybody remember? That's right. You take this negative. This is -1, and you distribute it. So I'm going to take this right here, and I got 5 minus I minus -5 plus 2i. I'm going to distribute that negative sign, which is going to give me 5 minus I plus 5, because I got a negative times a negative is a positive, and then negative times positive is minus 2i, and then I add like terms again. So what's this overall answer going to be? No, well, yeah, you got -3i is right. What else goes with it, though? What? 10. 5 plus 5 is 10. -1i minus 2i is -3i. This is what we're looking for. So we're going to do distributive of the negative sign. How many are thumbs up on subtracting? Okay, then the last couple sections we got, I guess 3 sections up here, this says write the conjugate. Now, we had conjugates like I had x minus 2. Let's say I had 3x, let's put 3x minus 2. What was the conjugate? Anybody remember? This is from what we did already this year, and you've done it in the past. What's the conjugate of 3x minus 2? Anybody remember? What? That's right, it's the same thing. It's the 3x and the 2. The difference is you just change the sign in the middle. So this is the original. This is called the conjugate. Remember doing that? Conjugate right here. So, can anyone tell me what's the conjugate of negative 7 plus 3i? That's right. You do the exact same thing. You just change the sign between them. Oops, that's a 3i, not a 7i. My bad. This should be a 3. Now it also says plot the complex number and its conjugate. So they want you to graph this as well. So if you graph this, remember that's I, that's R, because it says plot the complex number and its conjugate. I tell you what, well, let's not graph it, but I'm going to graph this one really quick, okay? Let's just write the conjugate down right now. So negative 7, you come out here to negative 7, you go up to 3, and you put a dot there. And then negative 7, negative 3, you would come down here, and the conjugate would be down here. Okay? Questions on that? All right, so we're not going to graph the conjugate. Then we want to do distance formula. Okay, so if you notice, the distance formula is the same. So we're going to do 43 here. Hey, what's the real part with the 6i? It is not 1. 1 plus 6i is not the same as 6i. 0. So when you have just one term, that means the other part is a 0. Am I going too fast? Okay, so we're going to do the distance formula of this. So you take the a part of this, which is what? 0, minus the real part of this one, which is what? 3. And then you take the imaginary coefficient of the first one, which is what? 6, and then minus the imaginary part of the other one, which is negative 4. So now you just do what you've been doing forever. So we get negative 3 squared, and I hope you realize that if you take minus a negative, that's plus a positive right there. So this is going to be plus 10 squared, which is going to be 9 plus 100. So this is the square root of 109. Does this seem pretty easy, or am I crazy? And you need to still practice it, okay? All right, then the last kind, no, take that back. No, yeah, the last kind, find the midpoint. So we're going to do the midpoint of number 46. We want the midpoint. So the midpoint is going to be the real part of the first one plus the real part of the second one divided by 2, and the imaginary coefficient of the first one plus the imaginary coefficient of the second one divided by 2. And it's an ordered pair. We write it as an ordered pair. And then this is going to be negative 2 over 2 and positive 2 over 2. So this is negative 1, 1 is the midpoint. And I'm going to see if they write it as a ordered pair, if they write it as a complex number here real quick. Because they might turn it back into a complex number. They don't. So I don't know how they're going to write the test, but it is possible that they might write it like this. Okay, they might change this back into complex form. You see how I did that? Just put the I back with this coefficient on 1. Does everybody thumbs up on that? So I'm not sure if they're going to write it as the ordered pair for the midpoint, or if they're going to write it back as a complex number. This number right here is also the midpoint of these two original ones. Yes, ma'am? I'll take either right now. I'll try to find out if there's a test made yet. And if it is, I will have you do it that way. Question? All right, so I'm gonna go back to the original problem, the original part that was up here. I hope you all wrote down, you're supposed to do 9 to 48 by threes on page 443. And I'm gonna put up that first page. You're starting with number 9. So number 9 is down here at the bottom. You gotta match it with the graph. If you don't have your book, I'm gonna leave this thing here. And I'm gonna shut off this recording and go ahead and